Good morning, and thank you for joining us. We have a great lineup today. I'll start with a drought and climate update, and then I'll turn it over to Joe Casola to do the outlook. And then we'll have Justin Chambers from DRI and the Western region talk about the Westwide Drought Tracker. And at the end, at the bottom of the slide, you can see it with atmospheric river there, which has been the highlight of this past month. Our two state climatologists, Mike Anderson and Steph McCaffey, talking about statewide drought perspectives. Before I start with the drought and climate outlook, I'd just like to do a brief summary of what NIDIS is. And so we are in the California-Nevada Drought Early Warning System. NIDIS' mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. We work to improve our understanding of how and why drought affects society, economy, and the environment, and to improve the accessibility, dissemination, and use of early warning information for drought risk and management. And so the Drought Early Warning System brings together these multiple components, so observations and monitoring, planning and preparedness, prediction and forecasting, communication and outreach. And together, this is what work towards the Drought Early Warning System. So with that, then, I'm going to go ahead and jump into the Drought and Climate Outlook. So many of these figures are from Mike Dedinger and then a couple of others. And what you're looking at here is the atmospheric river that made landfall on July 5th. This is a satellite image from the University of Wisconsin of Madison. And I will be talking a little bit more about some of the atmospheric rivers that made landfall over this month and the impacts from those. And so before we get into the details of the atmospheric rivers, this is just looking at the Drought Monitor for California and Nevada as of January 17th. You can see both states are still in some degree of drought that has overall generally decreased in this intensity of drought. This map on the right is looking at the 4-week change, and this light green color is 1 class improvement, and the darker green color is 2 classes of improvement. But overall, like I mentioned, there is still some severity of drought throughout both of the states, and with Nevada having 2 of the areas in extreme drought. So the next question is how do we get to this improvement and where we are so far in this water year? So if you look here, what you're looking at here is the year-to-date total precipitation throughout the West, focusing here on California and Nevada. This is in millimeters, but I put in some inches just for reference. So about 500 millimeters is about 200 inches, and just over 1,000 millimeters is about 400 inches. So you can see overall, we're doing quite well. And sometimes it's easier to think about this in terms of anomaly. And so if you're looking at percent of normal, you can see throughout much of California, especially this Central California and Central Nevada, in the Sierras, we're well above normal, almost 200 to 300%. In the southern parts of the states and more northern parts, obviously not quite as much as we are in the central region. So question is, how did we get here? So this is looking at the atmospheric river sequence that impacted California and Nevada, that started the day after Christmas, so December 26th. And each of these lines is representing a different one of the atmospheric rivers. And this is going out to the 13th. There were actually 2 additional ones, so I put here plus 2 more atmospheric rivers. And it was this sequence of atmospheric rivers and this back-to-back, the pacing of them, was really what was remarkable about these last three weeks. And the color coding is indicative of this is at the San Francisco airport, so at this specific location, the intensity. So we measure atmospheric rivers in how much water they hold and the wind, so it's called integrated vapor transport. So at this specific location, it's the maximum integrated vapor transport and the duration, and that gives us its AR ranking. And so you can see the ranking at San Francisco of these various different atmospheric rivers that made landfall during this period. And what this figure on the left is showing is how much precipitation fell during this period associated with these atmospheric rivers. And you can see for large swaths of the region in California and Nevada, it's anywhere from 30 to over 75%, with some regions in the Sierra Nevadas getting 100% of what their normal water year precip is in this 3-week period. So what did this do to the snowpack? And so if you're looking here, what you're looking at, this is an image from the Department of Water Resources, and the different snow water content in the north, central, and south. And this blue line is the current year, the current water year, 2022-23. And this is percent of average, or this is percent of April 1st snowpack. And so as many of the atmospheric rivers hit largely kind of in the central part of California came farther south, you can see that in the northern part there was an increase. So it's still at nearly 100% of normal April 1st snowpack. But as you go farther south, you're seeing this increase really in this amount of April 1st snowpack. And in the corner, I realize they're a little small, but I highlighted some of the statewide averages here. For year to date, the percent of average is almost 200% in the north, and 250 and 283 in the south. And so these storms really increased the snowpack throughout California. The one thing that I hadn't realized until looking at this map is how far ahead we are of the 1982-83 max currently. And looking at Nevada, here is the percent of normal for this time of date. And so likewise, almost 200% plus throughout the entire state. This is from the NRCS website, where you can see the basins. And this is actually this is one of the figures this is for Truckee. So the black line is where we are this year. The purple is the maximum for this basin historically. And here are the different percentiles by colors. You can see them on the side here. And then this X is the medium peak sweep. And so already for this year, it's above this medium sweep peak in the Truckee. And then just to show one other basin here as well, this is for the Humboldt Basin, where although it's still doing well and is in the top percentile range, it's the 98th percentile. It's showing it here, and it's very close to that medium peak SWE. It's not as it's not record breaking as it is in the Truckee. Just to give a snapshot of throughout the state where the SWE is. So one of the questions we have gotten is, what about soil moisture and how has this impacted deep soil moisture? And so this is looking at the soil moisture uptick since the summer at one location in the Russian River, which is in Northern California. You can kind of see it here about just north of 39 North. And this is 100 centimeter deep soil moisture, so relatively deep, one of the deeper measurements that we make. And you can see in November when it first started to uptick with some early storms, and then coming back down, and then early storms in December, and then these sequence of atmospheric rivers more recently, it's largely stayed up. So where you're starting to even see some of the deeper soil moisture increase throughout this water year thus far. And then this is from a modeling perspective. This is looking at soil moisture throughout the region, and this is a percentile-based system based on, it's called VIC, it's a hydrologic model. And you can see throughout much of the region in California and Nevada, the percentiles, in the 30 to 70, so kind of this normal range, what we think about, but then other parts of it between 70 and 90, except what we mentioned here before in the southern region, where you're not seeing that high anomalous precipitation for the water year thus far. And just looking at the 1 month change with a sequence of atmospheric rivers, in terms of percentiles, it's gone anywhere from 5 to over 45 percentiles. It's increased in improvement. So this series of storms, atmospheric rivers that have been experienced throughout the region has really increased that soil moisture impact. So one of the things another one is looking at stream flow. And so this is a figure from Mike Dedinger. And what he did is he looked at the natural stream flow that was averaged during this period of the sequence of atmospheric rivers, and how's that related to the percentage of total for what's normal for the entire primary wet season from December to February. And so in this area where most of those atmospheric rivers kind of really hit in the trajectories was largely in the Central California region, you see these stream flows being 100% of that normal December to through February period, but also throughout the state, just because of the wide region that the atmospheric rivers hit, being upwards of 200% throughout much of the region. The other thing Mike did that I thought was worth mentioning, because earlier in this year and in some of these webinars, we talked about how it was a La Niña year. And so what does that actually mean in terms of high stream flows? And so this is a figure that Mike updated. He originally created a while ago for a CNAP image. And this is the coloring of the circles are indicative of what the El Nino, the strength of the El Nino was. The blues are La Niñas, and the reds are La Niñas. And the size of the circles are indicative of the ratio of the largest flow at any of these stream gauges relative to the average peak flow. So, how big is the most extreme compared to the average extremes? And so what you can see is, generally in Southern California, most of these peak flows are during El Nino periods, which we often think about in terms of where El Nino may have ENSO may have the largest impact in looking at historicals in the Southern California area. But what I found really interesting is that when Mike originally did this in Northern California, a lot of those highest peak flows are during La Nina periods. And this range of mild to even stronger ones. And then each of these are just different specific stream gauges, and he highlighted where we are so far in this year in terms of peak flows and how does that relate. So they're all in that same line of, because we're in this La Nina period, but so far some of these peak flows actually haven't been as high as historically they've been experienced so far. The last thing that I'll touch on before I turn it over to Joe for the outlook is where are we in terms of some of the reservoirs. This again is from Mike Tetchinger and is on, I can send out the link in the chat when I'm finished. But this is looking at the reservoir storage in the 28 western reservoirs throughout California. And because snowpack actually can be a storage for water, he combines both the reservoir storage and the snowpack. And you can see for reservoir storage throughout the western Sierras getting pretty much close to normal. And then that snowpack, which we mentioned before, is well above normal for this time of year and very close to that kind of April 1st peak. Breaking down this a little bit more is looking at Northern California reservoirs, Central Sierra reservoirs, and Southern Sierra reservoirs. And you do see that even in the Northern California reservoirs, which didn't get quite as much as precipitation as some of the central and southern, it's pretty close to normal for this time of year. And then going farther south in central and southern, the central is relatively close to peak when you combine the reservoir plus snowpack, and the Southern Sierra reservoirs are well above that. And then this is a look at Lake Tahoe. Prior to the storms, Lake Tahoe storage was just at the rim. And then this series of storms really brought up the reservoir level, the lake level in general, and then the snow that is in the basin going into Lake Tahoe has peaked quite substantially. So not quite at that April 1st level, but there's been significant improvement in terms of storage in the lake itself and the snowpack surrounding the lake. Lake Lantan, looking here is, so this is a historical viewpoint, and the reds are record low or record high, and then going by percentile. So second is the orange, fifth is the green, 25th is the blue, and medium is this dashed line. And this bold blue line is the actual level. And so you can see this uptick from about 50 million acre feet to close to 100. So getting closer to that, almost 25th percentile for this time of year, but definitely has a way to go. So In conclusion, much of California and Nevada are about 150% of normal for this year in terms of precipitation. It was 9 atmospheric rivers between the 26th of December and 19th January that brought somewhere between 30 to 70% of a water year's total precipitation during these 3 weeks. The snowpack is over 200% for this time of year and over 100% of April 1st for many of the basins. Soil moisture has increased substantially. Deep soil moisture has also ticked up and the reservoirs are starting to fill up. So one of the questions we often get, do the ARs bust this drought? And my conclusions first is the recent set of storms have substantially mitigated many of the drought impacts, but it's too soon to tell the full impact of the ongoing drought. Some of the questions that we'll still be looking for is how much more precipitation and when will come, how much of the snowpack will transition to runoff. The groundwater recharge at this point is still somewhat certain, and in our region, it's very easy to slip back to drought. So always need to be planning and prepared for that. So with that, I will go ahead and turn it over to Joe.
Thanks, Julie. Let's see if I can get my slides up. Great, hopefully you can see my title slide. I'll try to look. I won't be able to answer all of Julie's questions about what's going to happen, but maybe I can shed a little light on a few of them. So just a quick summary of what I'm going to go through. I'll start with the 8 to 14 day outlook, which has elevated chances of cool and wet conditions for most of the California, Nevada area. I'll take a look at the monthly and seasonal outlooks, which not to probably surprise anybody, I don't think have a ton of information for us. They kind of show equal chances for any anomalies. And then I want to do just like a quick retrospective about what the seasonal and some of these long-range forecasts showed for recent events. And this is inspired a little bit by a Washington Post article that came out last week. The seasonal outlook didn't really give us much indication of this atmospheric river activity, but those week 2 to 3 forecasts did have some value. I think did kind of have some useful prognostications in there. I'll take a quick look at stream flow and drought. As Julie showed, the stream flows are much above average in a lot of California, and as far as the drought outlook goes, the continued improvement is called for in the northern portion of California and Nevada, but as shown in some of the places that have been missing rain, the drought conditions are expected to persist in Southern California and a large chunk of Nevada. And then I'll show a little bit about where we think ENSO is headed in the next couple months. So let's start with that 8 to 14 day outlook. So on the left are the chances. Remember, these are just probabilities. So the chances for below or above normal temperatures. And on the right are chances for above or below normal precipitation. And you can see broadly across kind of the western half of the country, we see elevated chances for cold conditions. And on the precipitation outlook, we see elevated chances for wetter conditions. And I want to take a quick look at the synoptic pattern that is coming out of one of the long-range models. And it is pretty busy. On the left, if you can see my pointer, you can see this pretty, so the green is the 500 millibar height contours, and the red dashes are anomalies that are positive, so ridging. The blue dashes are negative anomalies, so troughing. So you can see this pretty substantial ridge in the North Pacific, followed by this really, really elongated trough that kind of sets up by the West Coast and extends kind of over most of North America. So this is kind of the pattern that the models are leaning towards. That would bring a pretty screaming jet kind of across the most of the U.S. and allow a lot of Arctic air to kind of pour in, and probably a decent amount of precipitation along the West Coast. And I'll look at the hazard maps, and this is a little bit of a funky screen capture, but this is the 8 to 14 day hazard outlook from NOAA's Climate Prediction Center, and each of the colors here represents a certain probability for a certain hazard. So green is a slight risk of heavy precipitation. So you can kind of see that extending from kind of the Bay Area all the way up the West Coast. There is a slight risk of heavy snow in the mountains, kind of this areas all the way up to the Cascades. And then this broad area of either slight to moderate risk of cold conditions. And that's kind of the impact or the sensible weather we'd expect if we got that pattern that the models are kind of generating at that long time step. Okay, let's extend the our lead time a little more, and let's look at the February outlook. So on the left, and right, it's temperature and precipitation respectively. Again, it's probability maps. And here you see kind of heightened chances for cold in the kind of northwest, kind of dipping down into maybe the middle of California and northern Nevada for the month of February. And at right, you see the heightened chances for wet conditions, but really in the northwest, but in the California Nevada area, kind of equal chances or climatological chances. And this is a pattern you're going to see a couple more times in my slides. I think it's in some ways a bit of the canonical La Niña impact, which may or may not come to fruition, but that's, I think, where kind of the models head on these longer timescales. Lastly, again, very similar looking maps. This is for February, March, April, so kind of the seasonal outlook. And again, you know, heightened chances of cool conditions, heightened chances of wet conditions for the Northwest, with a little bit of that temperature tilting of the odds dipping into the northern part of California and Nevada. So I want to kind of do this retrospective again. This echoes some of what was in that Washington Post article. If you happen to catch it, the Post article kind of indicted that the longer-term forecast models for missing the atmospheric rivers, and I wanted to investigate that a little bit more deeply, or maybe kind of retread what they brought up, and also bring the question up of how do we really evaluate information from probabilistic products? A question I won't really answer, but just maybe reframe or kind of try to emphasize. So here was a seasonal forecast that was issued back in November for December, January, February. And again, you see that same pattern that we're seeing for February and for the next couple months, this kind of canonical La Niña, where you see kind of cold and wet, and this is just the precipitation part of it. So it's wet to the north and dry to the south. Obviously, this wasn't a particularly useful description of what just happened between the end of December and today. So even though that seasonal forecast didn't give us much, I would argue that 8 to 14 day product started to capture this. And this is the 8 to 14 day outlook issued December 19th. So it would have been valid the last week of December and the beginning of the new year. And you can ignore the temperature stuff for now, but at right, you can see this real bullseye of heavy rainfall. Now, it may not have been an exact deterministic forecast of where we saw rain, but you start to get a sense that some heavier than normal precip is in the mix. And I wanted to look at just the forecast discussion. I thought it was quite interesting that this is the text product that accompanies the maps, that there's some indication that atmospheric river may develop and bring enhanced precipitation, generally from Nevada and Utah westward through Northern California, Southern Oregon. Chances for above normal precipitation are particularly elevated there, even though the dynamic models do not favor the solution at this time, which I think this is very interesting. That last phrase is very interesting, saying that some of the models don't really have this, because when we're at this long time frame, this kind of more than a week, you know, we're not really deterministic forecasting anymore. We're getting kind of a spread of possible futures. And so this forecaster, Rich Tinker, who may be on the line, not to put you on the spot, but I think was kind of presciently highlighted that this might be in the mix, even though it might not be in kind of the major output of the models at the time. I wanted to also show another example of kind of this similar time frame. This is from the Scripps group, CW3E, and this is issued about the same week, 22 December, but it was actually a 3-week forecast. So looking at conditions that second full week of January. And they're basically calling for enhanced atmospheric river activity, and it's coming out of a number of their different model ensembles that they investigate. So kind of in summary, yeah, the seasonal forecast didn't provide us that much. information, and the seasonal and monthly outlooks, both in the past and actually going forward, seem to kind of gravitate back to just whatever the ENSO signal might be, which is, I think, a little bland and certainly was not a good description of the circulation for the last few weeks. However, those subseasonal forecasts did give us some information. So the unanswered questions I'll kind of leave folks with is, you know, is a long-term forecast that doesn't have atmospheric river activity really a bust, right? You know, when we're in this kind of probabilistic view, we're really looking for kind of a spread of possible futures, and are we kind of characterizing it appropriately when we say kind of, well, this is kind of your one forecast. Even I'm guilty of it, even showing that synoptic map earlier, right? There's probably more spread in the models than that one circulation pattern. So I'll just kind of leave that out there of maybe thinking of ways that we can better convey, you know, the possible futures at the long time scale, as opposed to saying, well, these are what we think the conditions are. I think we're getting there. I think obviously what CW3E has on their website is excellent. And I think maybe there may be more opportunities to standardize this type of discussion a little better. Okay, going to the drought outlook, Julie showed this. You know, obviously we still have a broad areas of drought, but we have had substantial improvement, especially in California. And the outlook product is here, and it shows in the tan and the green areas where we would expect drought to remain but improve, or drought to be removed entirely. The brown area shows persistence, and so we see persistence of drought in kind of the southern half of California as well as most of Nevada. Now that doesn't mean it's not going to rain or snow in these places. I think it's just it won't be enough necessarily in, you know, January, February, March and April to offset some of the drought conditions that we are experiencing now. Shifting to stream flow, this is really similar to what Julie showed. This is just the water year-to-date stream flow volumes relative to what the mean flow would be on this date. And you can see the blues kind of dominate most of the area here. Those are places with 150% of the average to date or more. And even those greens are going to be above 90%. So most of the state of California, you have really substantial stream flows. Northern Nevada, not as much. You see reduced stream flows as the snow that's probably feeding those places has yet to melt. As far as the forecast for the rest of the water year, and you can take this with a grain of salt, obviously there's a lot of the water year still ahead of us, but you can see kind of the same pattern, a real dominance of those blue colors showing kind of well above average stream flow for most of the state. And those places in Nevada do catch up, as I assume that snow that is sitting in the mountains would be feeding those streams by the end of the water year. A quick highlight of what's going on in the tropical Pacific. La Nina is still holding court. So on the left is a just kind of table of the ocean Niño index, which NOAA uses as one way to claim that there is a El Nino or La Nina event. And you can see these are 3-month averages. So steadily for essentially the past 3 years, since about the summer of 2020, the tropical Pacific has been in the blue squares here. It is in La Nina conditions. You can see that these are in degrees Celsius. It's holding court. Anything below ½ a degree Celsius would be a La Nina. So we're still solidly in kind of a cold equatorial Pacific state. And you can see the anomalies over the last 4 weeks of sea surface temperatures, and they haven't changed a whole lot. So La Nina is still in play. That said, the forecasts for the next few months are calling for a switch to neutral conditions. And so this bar chart, there again, these 3-month averages, blue is for La Nina conditions, gray is for neutral, and red is for El Nino. So kind of DJF, which is essentially almost our current state, it's La Nina. And then you see the gray bar kind of creep up and kind of take over by the time we get to spring. So the models are calling for this relaxation to a neutral state sometime in kind of the late winter, early spring. And I think that is all I had. Thank you very much for giving me the chance to present.
Great, thank you, Joe. I put this in the question marks and I was a bit remiss in saying this, but if you have questions, please put them in the question box, and those of us that are presenting will try to do our best to get to these, because I'm not sure we'll have time at the end. If we do, we'll try and leave a couple minutes for questions as well at the end. So with that, I'm going to go ahead and pass it over to Justin Chambers from DRI and the Western Regional Climate Center on a Westwide Drought Tracker update.
Thank you, Julie. Apologies for the light here, but let's focus on the screen. To that end, I'll make it easier to do that. So Dan McAvoy, our regional climatologist here, has been leading software development for the Westwide Drought Tracker that we host. And we've been able to focus on designing and redeveloping this tool with the help from NIDIS and the California Department of Water Resources. What you're seeing right now is the current version of the Westwide Drought Tracker. As you can see, we have current maps, archived maps, time series UI, and a data download UI user interface. The revised version of the Westwide Drought Tracker is split into two phases of development. The first phase will be centered on rebuilding these maps. This first phase is nearing completion, so I'll demo what that looks like here in a second. But just for some context, some of the map products that are available and will be available on the Westwide Drought Tracker point redo. We have drought indices. We also have departures and percentile rankings for temperature and precipitation. And then we split these into reasonable timescales. And if you want to see these maps split into your state of inquiry, that's certainly available here. And this page is showing you the current maps. If you were interested in archival things here, the current site supports that. So we decided we would start with the map section first here in our rebuild. We do have the same or very similar categorizations as the legacy one. So, but we haven't focused development on the archives of the chart tables. We just have these placeholders here. So let's just take a look at the maps. What you're seeing now, instead of just one map, we have a dashboard that shows you the current available maps, and then you can essentially switch your boundary of interest across 6 different map sections, dashboard sections, instead of having to go through it one at a time. We are right now showing a continuous color scale. We have development for these discrete binning of the data. We are in the process of getting out the door. But the main thing that we wanted to allow in this rebuild was interacting with the data. So instead of having these static maps, you can't tell right now, but I'm clicking on pixels in the map, and of course you're only going to get the visual color of the pixel, and you associate it with the color mapping on the right side. Well, we wanted to provide access to the data. And so one of the chief achievements here for us is we sort of rethought the way that maps should work. And we have basically unpacked the information behind the map. Instead of building map images like JPEGs and PNGs, we've decided to bring back the original data and do the image processing in the web browser in real time. And that allows us to get all this rich data that are inside the file. And it also allows for the opportunity in future releases for us to add actions. So, for example, I'm clicking here in this region in New Mexico, and we have a dry departure value here. Well, what if I want to compare that number against, similar numbers in the period record? Well, it's trivial now for us to add these action items to say, all right, well, here's a time series for the nearest grid point for this value. So a lot of exciting interactive opportunities arise from this approach. And we also have the ability to swap boundaries in and out. So right now we're looking at an overview of counties. Well, maybe you want to see it with HUCs instead. Switching those boundaries out on the fly is now a lot easier to do, since we're not really processing every single combination of data and boundary information, et cetera. So we can, it's highly customizable, highly reactive to user changes if we want to change a projection, for example. So let me go back, stay on the grids here. So let's say I want to see PDSI for the current month, but I want to see it in Albers instead of Mercator. Well, we crunch on it and there it is. And the interactivity is still there. The potential for actions is still there. And then as you saw, we have the ability to take this interactive thing, and if we want to put it in a presentation, well, we can flatten it into a PNG or an SVG with a clickable button, and there you go. So the dashboard that we will be releasing is a little bit closer to what you're seeing now in the second screen, where we'll have sections for precipitation and temperature departures, and then the rankings, and then the standard indices and Palmer indices for drought. Again, each section that has a time scale, you can change quickly on the dashboard. You can also get more custom time scaling in our product selector. So the dashboard is centered on current maps, so you don't have the ability to go backwards in time. This is a test data site. So right now, the most current data are through December 2022. But if you need to go back in the archive, you can use the product selection, select your product type, select your boundary of interest, select your measurement of interest, and then if you want an archive, just go grab the year that you want. So 2020, and then the ending month of the period that you want, and then your projection, and there you go. So that's how we collapse archive and current maps into a single map user interface. The other product that I'd like to show, I suppose I should show all three products that will be available when we release this. The release date is somewhere in February, is our target release to the public site. So these will be available very, very soon. We have right now 3 different types of maps. If you want an isopleth map, which is more of your contouring over a pure SVG format, we certainly support that. I'm not going to run for continental US right now because that takes quite a while to produce the contours on the fly. So this is happening in real time. Let's just pick something randomly here. I just want to show you the product that we have here. So this is also interactable, but the data, the underlying data are written over with leveling. So, this product is not necessarily as data rich as the grid that I just showed you, but it has its usages if you are interested in just something light and fast and seeing some contouring. If you like this format, I guess is what I'm trying to say. So that's an example of the contour map. Of course, you can download all these as SVG or PNG as you like. The other, I showed you the continuous one. I'll show you a little bit of the gridded one. This one has a more pixelated approach on the data, but the advantage is that you do get the actual value for that pixel area. So 3 different types of map products versus the one that we have in the legacy site, and more dashboard sections are available in this new update. And the main thing is the interactivity with the data now, which was not available in the legacy site, but will be available in this update. Those are the main highlights I wanted to hit here. Thank you, Julie. I'll turn it over to the next panelist.
Great, thanks, Justin. Justin, there was a question for you in the chat about is the Westwide Drought Tracker broken down by county, I believe. So if you maybe want to answer that, and Mike, do you want to bring up your slides?
The Westwide Drought Tracker does have maps broken down by county at certain state levels. So what let me put my, well, I guess I can just say that if you're looking at CONUS, right now we break down CONUS by states. If you want a sub-region of CONUS, those will have state boundaries and counties in it. As we roll out the time series, though, we know that we want to have those broken down by counties individually. So the plan is to recreate that time series data breakdown at that point.
Okay. Thanks, Justin, very much.
Thank you.
Mike is a climatologist for California, and he's going to give us a perspective about California's drought status from the state perspective. So I'll turn it over to you, Mike.
Thanks, Julie. All right, everybody. Just want to show kind of 2 perspectives of what California's world has been. On the left was during the Parade of Atmospheric Rivers, shot from the California Nevada River Forecast Center's webpage, showing the different river forecast points in either flood stage or monitor stage, including both main stem, Sacramento, and San Joaquin rivers, as well as many of the coastal locations. One area you do note that kind of missed a lot of this event would be the Klamath Basin and far northern part of the state. And then on the right, you see our precipitation forecast over the next 6 days from last Friday through the next Thursday. Pretty much nothing. So in kind of the all or nothing world that we started to experience last year, got turned up this year. Let's see if we can move down, maybe. All righty, there we are. All right, so what are we coming off? Well, 20, 21, and 22 beat out 13, 14, and 15 for the driest 3-year stretch in observed precipitation. Records dating back to 1896, so to do it twice in the last decade is pretty impressive. Dry expectations were for this year with triple dip La Niña, and things changed quickly after Christmas. As Julie mentioned, there are 9 atmospheric rivers in their landfall locations with their strengths. This produced by Chad Hecht from the Center for Western Weather and Water Extremes, and he has been working with us in our flood operations and hydrology and flood operations office here this year, which has been an absolutely fabulous partnership. Just for comparison, 20 and 21 combined, we only had 3 strong atmospheric rivers impact California. So big difference there in a quick 3-week period. What does 3 weeks buy you? Well, it buys you 80% of a full seasonal snowpack. About 46% of a full water year if you average it over the state. Understanding that the whole state didn't get that. Some got much more and some got a lot less. In those areas that got much more, we had 8 new floods of record. So this event will go down in the history books. Where does that leave us? Well, we still have shortage concerns in the Colorado River Basin. Shasta Reservoir is still 400,000 acre-feet below its average storage, and Trinity Reservoir is still about 750,000 acre-feet below its average, and currently Trinity holds 748,000 acre-feet. So, as I said, those far northern reservoirs, and these 2 reservoirs are the largest reservoirs in the Central Valley Project. Missed out on a lot of that gain that was made now. There was a lot of effort made to capture as much storage as we could in our reservoirs. And San Luis made some pretty significant gains in that time. And San Luis is our off-stream reservoir south of Delta for both state and federal water projects. And it did manage to increase storage back up to about 73% of average. And those gains will continue as long as conditions remain positive for moving water. Wait, measure our groundwater gains as we kind of see where the spring high measurements may lie. And the other concern we want to is what happens between now and April 1. Experience from last year sure taught us that, boy, you can start strong and have everything turn off. And the next 2 weeks kind of give you that sense it might be doing it again. But as Joe indicated, there are some indications there in early February of maybe a switch back into some heavy precip. So challenges abound, and a lot of it comes down to how do you manage the volume of water that shows up. It's, as we've seen, when you have massive amounts of water all at once, there's really only so much that's managed for benefit. The rest is managed to mitigate hazard. And as we get into snowmelt, there may be that same challenge of how much can you manage for benefit and how much has to be managed to mitigate hazard. For those of you that want to follow along from the state's perspective, at the Department of Water Resources, we stood up the California Water Watch web link there in the slides for you. If you Google California Water Watch, it should come up as your first option. And there's where we've kind of made a one-stop shop for the state's monitoring data in graphics that are friendly to download and use for media interests. Anyway, with that, I think that's the end of my slides. So I'll quit sharing and we can keep on moving.
Great, thank you, Mike. So Steph McAfee is now going to present on the drought outlook or drought status from a Nevada perspective.
Hi, everyone. So I think I will actually be saying many of the same sorts of things that Mike said. We're constantly getting questions now, right? We've had all of this rain and snow. Are we back to normal yet? And, you know, if we take a very broad brush view, the snowpack looks great so far throughout most of the state. We're, you know, at twice where we would normally be for this time of year. And even the upper Colorado basin, which of course supplies most of the water to Las Vegas, where actually the majority of Nevadans live, is also in decent shape. Not as good as the Sierra and the Great Basin, but better than it has been. And one thing we do see is that if we look back at previous years that were kind of this far ahead in, for example, the upper Humboldt Basin, we do see that most of the time these years remained a little bit better than normal, but there's also been quite a lot of variability in just how much better than normal they are. You can see here we are, this black line, versus 1983, this green line, which was actually a little lower than where we are now.
Hey, Steph,
yes?
we're still seeing your front slide here.
Huh. Okay, thank you, because I am a couple slides in. So show Microsoft PowerPoint. All right. And
we're seeing the slides on the left too. We're not seeing the full screen.
that is weird. You know, this may be one of those fun Mac issues, so maybe we'll just go with y'all seeing the slides on the left. You'll get a little preview. Okay, so to quickly recap, good snow year so far, and most of the previous years that have been this good have remained relatively good, but there's been a lot of variability, from very extreme snow years to just slightly above normal once we get to peak SWE in April. And if we ask whether we've gotten normal precip so far for this water year, well, it depends where you are. Parts of southern Nevada and parts of northeastern Nevada have actually been kind of very close to or even below normal, whereas other parts of the state have been much wetter. And if we take a longer view, going back to sort of the start of the 2020 water year when we got into this drought, whether or not we're normal yet really varies. If you go to some place like Reno, essentially, yes, we have almost made up that really long-term, pretty large precipitation deficit. If you were to go to someplace like Elko, it's a lot closer. But in some place like Las Vegas, we would have expected about 14 inches of total precipitation since the beginning of the 2020 water year. They've gotten just under 9, which means we're short over a year's worth of precipitation still, with not a whole lot in the forecast for Las Vegas. And of course, we started the calendar year with many of the reservoirs we really depend on in not so great shape. So this is late December, percent reservoir capacity in the blue bars. Those diagonal lines just are showing reservoirs that I couldn't get data for when I made this chart. And we can see some of our reservoirs are great. Up here, Marlette Lake, Boca, Donner, Independence, all the way down to Stampede are in the Tahoe and Truckee basins, and they're doing pretty well. And then also got the brunt of these early January storms. But Lahontan Reservoir was at 10% of capacity. It's been low for a long time. Rye Patch in the lower Humboldt is still at less than 10% of capacity. And of course, you know, Lake Mead.
Steph, sorry, real quickly, can you just
Yes.
take your PowerPoint and move it to the right a little bit? Some of the slides are cut off a little. Perfect. Thank you.
That's so weird because it's just supposed to be showing the window.
Yeah, I don't know what's going on.
I don't know
but
either.
Now we can see the whole thing, so thank you.
All right.
Perfect.
And so, of course, Lake Mead has been low, and you know, as of December, even the most optimal or optimistic outlooks didn't bring Lake Mead out of level 1 shortage conditions. And in fact, most probable inflows suggest we're looking more towards continuing level 2 and maybe dropping into level 3 shortage conditions. So from a drought perspective, things are clearly better than they were, but it's not entirely clear what the next few months will bring. And there are some long-term deficits and some structural challenges that even one great winter won't fix entirely. So when we start thinking about, are we back to normal yet? Are we out of drought? In some ways, we are on a good path towards being out of drought, and in some ways, we have a lot of other significant changes, many other significant changes to make to be more resilient to drought.
Well, thank you. And all our presenters did an amazing time sticking to time. So we do have actually a couple minutes for questions. I tried to answer some of them during the questions, or sorry, that came online as others were presenting, but obviously didn't get to all of them. So I will try to, something just happened. There we go. Joe, I think this one, and if all the presenters don't mind turning on their videos if they had them before, so they can see us in the windows, that would be great. Joe, there was one question for you about, can you post the Washington Post article that you referred to in the chat? I didn't have it handy, so I wasn't able to do that. The next question was, can you discuss the influence of La Niña on the development of ARs? So this is super tricky and really complicated, and there is no simple answer. And I welcome others to chime in here, but it's there's various different teleconnections between the tropical specific and the winds and the storm track. But looking at, some preliminary analysis is looking at also too what's happening off the Asia continent and setting up the elongated jet, and then feedbacks within the atmosphere that made this very stable for this event in particular. So I don't have a good simple answer for this. I don't know if others on the call have a more simple, straightforward answer besides that it is really complicated.
Well, one of the things to look at is the way we characterize La Nina is a really seasonal perspective, right? A 3-month average. Well, you're looking at what it looks like for winter. Very different when you get into a subseasonal pattern change that really is reflective of the more dynamic state of elements within the climate system. So if there is a surge of warm water that redistributes the heat within the Pacific Basin, that can influence a change in the storm track that would lead to a temporary, albeit impressive, extension of that jet stream and the reduction of that high that was keeping us dry up until Christmas.
Thanks, Mike. So the next question was about seasonal forecast, and then it was, do seasonal forecasts not capture simulate the AR activity well, or are they just not getting the latitude of the landfall right? The models that inform the seasonal forecast project ARs, but just more as a Pacific Northwest system. So I can make one comment, and then I know less about the NOAA seasonal predictions and what all goes into them. But one thing I will say is when you get out to those longer timescales, subseasonal or seasonal, you often reduce accuracy in terms of exactly where an atmospheric river or the storm track will hit. So the position errors are generally larger. So for that longer lead times, you often decrease that precision in location. It's one of those trade-offs. I don't know if Joe, if you can talk a little bit more about what goes into the NOAA seasonal predictions and discuss that.
Yeah, so on those longer time scales, El Nino is a really big factor, and kind of the conditions in the ocean, as is soil moisture, which matters more over the continent. Adding on to Julie's comment, the other thing we should keep in mind for these long range forecasts is they're really not deterministic. We're not going to be able to tell you what the atmosphere looks like for, a couple of day period or a week long period, even one that's very impactful, like what's happened on the West Coast. We're going to be able to give you the odds. It's kind of like going to the casino and you get kind of the odds for figuring out, a different roll of the dice. And so that's really what these models are kind of built to do, as opposed to nail the exact state of the atmosphere at that long term. So it has to be interpreted a little differently than just our weather forecasts, which are often deterministic. And we have to think about, what are the chances of certain things happening. And I think, like Julie and Mike said earlier, at the seasonal time scale, trying to get a week or a couple week period for a particular flow pattern is very challenging. And I think that's just too high a bar right now for our capabilities.
Anything else, Mike or Steph, that you want to add? Okay, I just wanted to make sure. Are we seeing additional ARs in the 8 to 14 day forecast? So this is kind of on the cusp of that. From what I'm seeing, it's very early February, whether it's the 2nd, 3rd, 4th, or 5th. It's still a little uncertain, but it's looking like that the door may open up again in kind of the edge of that 8 to 14 days.
Yeah, although I will say when we look at that, it's still looking like for California and Nevada, it may be a relatively lower end storm, like a lot of the moisture might be going to the north. Of course, 8 to 14 days out is, there's quite a lot of uncertainty. So.
All right, okay. I think we have one time for one last question. You showed less skillful seasonal predictions of the AR's activity during the past weeks based on MSEP CFS2. Do you know how ECMWF did for the seasonal prediction of these AR events? I don't have the subseasonal look off the top of my head from ECMWF. I know so normally on CW3 we have these, but we were having some trouble with the data stream because it had changed. So I don't know if we have that data. I don't know if anybody to look at. I don't have it off the top of my head or no.
Yeah, I would just point to that website where the outlooks are done, and you can go and look at that for some of the previous events too. Not just kind of what's coming, but you can take a look where they have assessed kind of whether these were in some of those subseasonal models.
Yeah, and I would say in terms of looking at this 1-2 week window with a lot of storms, I wouldn't put a lot of stock in, well, this model got it in the deterministic forecast and this was less good. Some of that is just going to be luck as in on top of skill. So.
Well, with that, since we are at time, I will go ahead and wrap up. Thank you so much for joining today. We will post the recording of this on the NITIS YouTube channel in the upcoming days. And thank you all to our presenters for taking the time to be with us today. We really couldn't have these NITIS webinars without you. So thank you, everyone.
Thanks, everybody.